Okay, so hello everyone. Today I will present the prediction of centered ALN ceramic properties using coding or machine learning. So let's get started. The ALN itself, let's talk about the ALN itself. So ALN itself has high thermal conductivity, close coefficient of thermal expansion to silicon, excellent thermal and chemical stability, and electrically insulative. This characteristic make it ALN is a good candidate for thermal conductive materials such as this in this picture. So it's connect the power module with the heatsink to help the thermal management. But for the there is some requirement. It needs to be a high purity ALN to create high thermal conductivity TIM, thermal interface material. With the impurity can be carbon or oxygen, mainly the oxygen, and then the sphericality of particle which can affect the sinterability. Because the research context itself is to create a sample which with high density and high thermal conductivity. There are several variables that can affect the final results of the sintered ALN, but we will discuss later. So the coding will be applied to predict the final properties, which is the thermal conductivity, density, and grain size based on the processing condition and composition. And we can use also the machine learning to analyze the trend and support the future optimization. Some kind of tools that will be used is Python, Pandas, NumPy, and scikit-learn. So this is the process overview. The process will start at pre-process, encoding the categorical data and scale features, and then split the data into training and test set. And then we will train a multi-output regression using a random forest regression, and then predict and evaluate the results. So first there will be 7 experimental data set. It will include these input features, and there will be 3 target output. As mentioned before, it will be grain size, density, and thermal conductivity. So let's get started to the code. So first, here is the code. First, we use the pandas tool. This will be used to analyze the tabular data or just to read the Excel that we input either as a base data or as an input. And then NumPy will be used to do the numerical operation on arrays, and the scikit-learn is to import this kind of thing like the trend test split to split the data into trend and test set. This one is to do the scaling number and to encode categorical data into numerical or binary number, and then column transformer and pipeline. This will be used for pre-processing. Multi-output regressor, this is to predict several output at once, which is there is 3 output, and random forest regressor will be used as a main machine learning model. Why? Because our data is not that big actually, so it's probably between the small and medium dataset as a starting, and this model will help to avoid overfitting, and this model also can do like linear or non-linear. So it will be good for our model, and it also supports multi-output. And lastly, the scikit-learn also import this function which to calculate the mean absolute error and also the R squared. And first we map for the additive. This is to create simple code and readable labels for later. So here, this is to load the base data. So here is the base data that will be used. You can change this based on what your data set that you use to train the model. And then here we use the panda to read the Excel and create it into a data frame. And then this data frame will also be make sure to there will be no X and none together. And that will be read means at will be read the same. That's what I mean. And then we divide in input and target column, which column is input, which column is target, and separate this input and targets. And here is the pre-processing. At pre-processing, the standard scaler will normalize the numeric columns, which is this, and the one-hot encoder will change the categorical feature, which is the additive codes, which we already changed in the previous slide into XABCD, into a binary columns. And this is the pipeline to create the model step, to chain all the pre-processing into the model step. Now we will split the data into train and test set. We split the data 80% for training and 20% for test model performance. Here we use 80 to 20 ratio because it's in well accordance with widely accepted ratio for doing this kind of coding, and it's also providing a good number, especially for our small data set. And here is there will be a choice for the user which they want to show the model performance, yes or no. And if it's yes, it will take a predict targets for test set and then show you the MAE for each target and the R squared for each target. Next, I make the data input into two mode. So mode A will be the Excel mode, so you can input Excel file into the program, and the program will just read it using the pandas tool, read it, and then it will create a data frame, and then it will predict from this data frame that's already been read directly, and it will show in two things. First in the console, and it will also save the output into a new Excel file. For the second mode, it will be a interactive or manual input mode. So here you will input your data manually, input the variable manually, and if you want, this can be used not just for single, it can be used for several data. So it will ask, do you need to input another sample, yes or no? And it will create a data frame of a new sample and then predict the manual input and show it in the console. But this one is will not save to the Excel just for efficiency because the data usually is not that much, right? Only single or several data. And this is else. This is just for if you choose another then mode then A or B, it will just make you choose between A or B. And lastly, to create a loop, just an asking, do you want to make another prediction? Otherwise, the program just will be finished. Now, this is how to use the program. So first, we will run the coding, and at first, it will you need to choose whether to show model performance on test data. If it's yes, like this, it will show you the MAE and the R squared. By the way, this is the base data that's mentioned in the coding. So if it's not base data, just like just any collected data, you need to change in the coding into collected data. But here, so when you choose A, you it will ask what is the Excel file name. In this case, I choose the name experiment1. So here experiment1, and it will directly show you the result in console like this, or you can get an Excel of the output here. And then for the second one, for the second mode, you can start again, like start the program and then choose whether you want to show the model performance on test data, or you can just use directly from the previous mode. Just choose yes for another prediction, and you will need to choose another mode, choose the B one, and here you will input the variables one by one. And if you choose additive code X, it will instinctively set the amount into 0% automatically. And here I show an example using two samples. So just click yes, and then it will show another. You can input another sample, and if it's already finished, just choose no, and then it will show on the calculation. Here in the final script, you can make another prediction, yes or no. If it's no, then it will exit the program. So the benefit of this type of coding, it will allow us to get an early prediction of the key ceramic properties. It will also help reduce experimental costs because it will make the experiment efficient, because we know what is the predicted number, what is the variables that we can try to find. Oh, this one will get a good result, so we just choose the good result one, and it will help to reduce the workload and the experimental costs. And for the future work, we can expand more data set with new experiment that we've been done, or another data coming from partner institution, or another paper they just collected, it will make the program much more accurate and give a much better prediction. And lastly, probably we can expand the program even further. What is even further here? We make it reverse. So we input the desired result and it will create what is the variables needed to create these desirable results. So this work can be expanded even more, but for now, I think this is enough. So thank you for tuning in. See you.